All right, today we're going to have a short lesson on the Pythagorean theorem converse. Okay, the key word here is the converse. All right, the Pythagorean theorem we know is a squared plus b squared equals c squared, right? If something is a right triangle, okay, then we can use the Pythagorean theorem, right? So the converse is going to be if a squared plus b squared equals c squared on any triangle, right, then it is a right triangle. Okay, so the Pythagorean theorem says that if something is a right triangle, then we can use a squared plus b squared equals c squared to find a missing side. The converse is just kind of the opposite. It's saying, well, maybe we don't know it's a right triangle, but we know all three sides. Then we can use a squared plus b squared equals c squared. If it is equal, then it's a right triangle. So for an example, let's say we have a triangle, and usually, it's going to look like it might be a right triangle, but we can't tell exactly, okay? And sometimes they don't even give us a triangle. Sometimes they'll just give us A, B, and C, okay? But anyways, let's say we have, 4, 6, and 8. And the question is this a right triangle? Is this a right triangle? Okay, so it's going to be like a yes or no answer, right? So we're going to check by using a squared plus b squared equals c squared. So let's try 4 squared plus 6 squared equals 8 squared. And we're trying to figure out if this is true, okay? Are those two sides of that equation equal? Well, 4 squared is 16 plus 6 squared is 36 equals 8 squared is 64. So when we add 16 plus 36 together, we get 52 equals 64. Well, that's not true, right? 52 does not equal 64. So that means a squared plus b squared does not equal c squared. So no, it's not a right triangle, okay, because they're not equal, all right? Now, what if we had, let's say, how about 6, 8, and 10? Let's try this one. So we're going to check again. 6 squared plus 8 squared, does that equal 10 squared? Well, 6 squared is 36, 8 squared is 64, 10 squared is 100, 36 plus 64 is 100, so 100 equals 100. So yes, since they are equal, that is a right triangle, okay? So that's all it is, plugging in the three sides. If the theorem works, then it's a right triangle. If the theorem does not work, they're not equal, then no, it's not a right triangle. And then one more example, because I know you guys are going to see a problem like this coming up here. Let's say this is 3. Maybe this is 2 root 17. And over here, this is, how about 5? All right, so we're going to check this one, okay? 3 squared plus 2 root 17. That's this bottom side, right? So that would be the whole thing squared equals 5 squared. Okay, so this, sometimes you're given the square roots on the side, so I'm just showing you how we're going to cancel those out. So 3 squared is 9 plus, when we see something like this, I have to square the 2, okay? 2 squared is 4, right? And then root 17 squared, whenever we have a square root squared, it just cancels out. So this would be 4 times 17 equals, on the other side, 25. So 9 plus, well, 4 times 17 is going to be 68. So this one is actually nowhere close. 77 does not equal 25, so it would be no. Okay. Just wanted to show you guys one with a square root in it. Sometimes you won't even have the 2 root 17. Sometimes it'll just be, maybe this is the square root of, just the square root of 17 without the 2, okay? If that happened, when I square it, it just becomes 17. Over here would just be 17. So just be aware when you see the square root, when you square it, it just cancels out, okay? And I still had to square this 2 if there's a number in front of it, okay? And that's about it for the Pythagorean theorem, converse.